under decimals, please, ladies and gentlemen. Under decimals. Today we talk about repeating decimals. Repeating decimals. And here is the gist of that. Okay? A lot of fractions end up being turned into decimals that are really easy. For example, 1/5 as a decimal is what? 0.2. And one way that you, God bless you, one way that you can figure that out is how do I turn 1/5 to a decimal? Well, really, this fraction is a division problem. You divide 5, divide it into 1, and you end up with the decimal 0.2. Well, there are a good number of fractions that don't work out nicely. Some of them you know, some of them you don't know. For example, 1/3. Okay, if you change this to a decimal and do that same division, gizmo, gadget, whatever stuff, what happens? Well, 3 doesn't go into 1, 3 goes into 10 3 times, which is 9. 3 goes into 10 3 times, which is 9. Keep bringing down zeros, 3 goes into 10. You get what we call the dreaded repeating decimal. How do we show that a digit repeats? Because you don't want to write down 3's for the rest of your life, which is what you'd have to do if you actually had to keep going until it worked out, which you never will. What you do is you take and you put a line over the digit or digits, sometimes more than one digit repeats. So you'd read that as 0-point repeater 3. These things, by the way, have a name. I don't know if I've ever said it in the world before, but the digits that repeat are called the repetends, R-E-P-E-N-D, repetend. You put a line over the repetend, and I don't know if that's plural or not, but I figured since it was in the book, that might help you. Now, every fraction, ladies and gentlemen, that is why we've talked about rational and irrational numbers. Repeating decimals are rational numbers. They make sense because if it is in fact a repeating decimal, it is somewhere a fraction somewhere. A repeating decimal always comes somewhere from out of a fraction. Things that irrational are decimals that never end but do not repeat. If you look at pi, you look at all those decimals in there, nowhere in there is a pattern of digits that repeat. Pi is irrational because it just never works out. Okay? But if you end up with a decimal that repeats, and actually in 8th grade, 3 days ago, we did it. There's a way to change repeating decimals into fractions, back the other way, but we're not going to get to it. It's kind of complicated. Now for example, here's a good one for you. What is 1/7 as a decimal? Well, if you take 7 and divide it into 1, check this out. I love 1/7. I'll keep adding zeros. It eventually will repeat. It might take a while. 7 goes into 10 once, that's 7. Bring down the next one. 7 goes into 30, what? 4 times, that's 28. 7 goes into 20 2 times, that's 14. 7 goes into 60, what? 8 times, that's 56. It hasn't repeated yet. 7 goes into 40, what? 5 times, that's 35. 7 goes into 50, 7 times, which is 49. 7 goes into 10, how many times? Once. Now, well, let's do one more time. 7 goes into 10 once, you get a 3. Once you see this, see look, this 3 is going to give you 30, and then you're going to go back to 20 and 60 and 40 and 50. Once you see that you started again with that 1, you know it's just going to keep going 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. Where do I put my little line? You put the line over the digits that repeat, so the little line is actually going to go over all of these digits. Don't put it over that second one because that would throw the pattern off. 1/7 as a decimal is 0.142857 repeater. And the other thing to keep in mind is this. If you had 1/7 times 8, okay, you are not allowed really to do mathematical procedures with repeating decimals. For the simple reason it won't be accurate because there's no way for us to really do this. You can't just pick those first 6 and say that's right on the money because it's not. So if you see a repeater decimal, you need to change it back to its fraction and then do the math with it as a fraction. The answer to 1/7 times 8 is 8/7 or 1 1/7. You can't say, okay, I'm going to change 1/7 to a decimal and put 0.142857 and multiply that all by 8. You'll get an answer that's pretty close, but this is exact. This would just be close. Fractions are always, well, they will be in that case more concise and accurate than decimals will ever be. So the same thing when you see this, 0.3 repeater times 6. You can't just take 0.3 and multiply by 6 and say my answer is 1.8. You have to know that 0.3 repeater is what fraction? 1/3. And you multiply that by 6. And that ends up being 2. This is the answer. This is close, but it's not exact. So when you see those repeaters, you definitely need to change them. Here, let me give you this one. Oh, and here's some you should know. Let's write these down so you have them in your notes. The ninths are always interesting. You should recognize these when you see them. Everybody know what they are? Good to have in your notes. First of all, you know a couple of these because 3/9 is the same as, if you reduce it, it's what? So 3/9 as a decimal is 0.3 repeater, you might not like that. 6/9 is the same thing as 2/3, which is what is a decimal?
0.6 repeater.
0.6 repeater. Maybe you see the pattern here. 3/9 was 0.3 repeater, 6/9 was 0.6 repeater, so guess what 1/9 is? Yep. 1/9 is 0.1 repeater. 2/9 is 0.2 repeater. 4/9 is 0.4 repeater. 5/9 is 0.5 repeater. 7/9 is 0.7 repeater, and 8/9 is 0.8 repeater. So you should have the thirds. How about the sixth? 1/6, 2/6, 3/6, 4/6, 5/6. We know 2/6 is 0.3 as well because of that, and this is also 0.6 because it's the same as 2/3. What is 1/6 as a repeater? Well, let's do it. 6 goes into 1, 0.1 times. 6 goes into 40, 6 times, which is 36. You're going to keep getting 40s. So what would it be? What is it?
1.6 repeater.
Not 1.6, but
0.1
0.1 repeater 6. 3/6 you already know because it is the same as a half. 0.5. 5/6, I believe it's 0.8 repeater 3. Take 6, divide it into 5, you get 0.8 is 48, you get 20, which is 3, and you keep getting 20, so it is 0.8 repeater 3. And it's good to have those in your notes so that when you come across them, you don't have to sit there and try and figure out what it is, you automatically know what it is. The 8s don't repeat, so you don't have to worry about those. The 5ths don't repeat. 7ths we don't worry about, they get a little goofy. And that should probably get you to the place where you need to be. Welcome to the wonderful world of repeaters.